Hello, everybody. My name is Stefan Plantikow. Could we get started, please? Thanks. Hello, everybody. My name is Stefan Plantikow. I'm the lead of the Open Cypher language group at Neo Technology, and I want to talk today about evolving Cypher for processing multiple graphs. And I have to stay a bit close to the keyboard. So just quickly about this talk, this is a proposal for working with multiple graphs. So this is not this extension to Cypher that we have agreed upon doing, but we certainly are very closely investigating how to add support for multiple graphs to Cypher in general. Just before I start on the actual topic, I want to give a quick summary of our first Open Cypher's implementers meeting, which happened yesterday just here in Waldorf. We had a really great list of attendees, about 35 participants from 9 companies, 3 universities, and it was a really great day, and thanks again for everybody who is now also here who attended yesterday. We made quite a few interesting announcements. For example, Neo4j's Cypher frontend is going to be liberally licensed very soon, most likely under Apache license. We made new releases of the TCK, so the conformance test suite of Cypher, as well as our grammar. We are starting a formal collaboration with the University of Edinburgh on working on the notational semantics of Cypher to have that side of things covered and really worked out precisely. New Cypher implementations have been announced. For Redis, for example, we have an implementation of Cypher on Postgres by Korean company Bit9. dgraph and memgraph are considering implementations of Cypher. And last, not at all least, we put forth a proposal for forming the Open Cypher Implementers Group, the body for working on a standard for a property graph query language based on Cypher. With that away, let's look at where Cypher is in 2017. So Cypher is the most widely used declarative query language for property graphs at this stage. We are continuously adding new features like conjunctive regular path queries, subqueries. We're taking on homo and isomorphism, essentially having decided to give people all the options, so making the language in the core be homomorphism based, but allowing also people to stay in a relationship and node isomorphism as needed. New kinds of constraints, etc., right? Although, of course, Cypher still returns only records, right? And that's the topic that we've been talking about here in the LDBC TUC all morning, essentially where we are today, right? We access a graph and we return a table, right? And of course, it would be lovely if a query language were closed under graphs and just operating on graphs. Or to put it into different pictures, right? We are here, right? We access a graph, we have query parameters, we have a query, we output records. It would be much nicer if we were able to output graphs or input graphs. I want to touch just briefly on the motivation for all of this, which I think is also important to always keep in mind what are the actual use cases. And I think there's a large spectrum here actually going from the large, which is essentially about topics like graph management, federation, access control, and these topics, towards maybe conceptually more towards the small, where we get more to modeling concepts, right? And in the middle, you have things like, of course, views, very important topic. You have topics like graph visualization, which may make it interesting and relevant to return graphs. And then on the modeling side, of course, you have intergraph operations. We saw some of that popping up in the morning, like intersecting graphs, union graphs, etc., etc. And then last not least, the modeling bit, how do you represent a route as an object, right? How do you refer to a fraud ring as an object, right? So that's where graphs become really interesting as first-class citizens of the system. So, of course, taking a change like that impacts the whole stack, right? I mean, that's not a trivial change. You have to think it through on the physical model, you have to think it through on the logical model, right? It affects the language model, goes all the way up to the client. I mean, we've seen that, I think, also in the discussions around how could it fit into SQL. It has impact on existing infrastructure, existing features, right, that need to be very well considered in order to end up with the holistic whole approach. So let's talk about some of these issues here. So first of all, on the physical layer. So the idea here under this proposal is today, of course, we have a graph, right? Like in a graph database management system like Neo4j, might be persisted to disk, right? And it contains essentially nodes and relationships with their properties, right? And clients access that. And so how could that change, right? If you want to talk about graphs, they need some kind of containment on the physical level, right? And the idea is to say you have a notion of graph space that essentially contains node relationships and graphs, right? And then a graph space could have attached to it a characteristic like being persisted to disk, or maybe also being of a different nature, like being in a memory session or being a snapshot, et cetera, right? And then if you zoom out of this picture, of course, it is completely foreseeable that you could also be talking about federation at some point, right? Having graph spaces managed by multiple graph database management systems. On the logical model, we think that graphs are first-class entities and should be treated as such. So this is clearly an extension of the property graph model. So a graph would have identity, it would have a graph type or possibly multiple labels, right? It would have properties, right? Then also, when extending a model, it's also always good to think about the restrictions. So of course, a graph would contain nodes and relationships. It would contain the nodes, the relationships. But if you look at the history a bit about the hypergraph model and how I think the hypergraph world has struggled with their models being understandable, I think as a field, we need to also see that we come up with a model that has appeal to actual end users and application programmers. And so we, at least for now, have considered to say we will not consider half relationships. So a relationship and its end nodes always have to be in a graph to keep things a little simpler. But of course, that is a restriction that can be lifted if need be. So one I want to point out that's maybe not immediately obvious here, that there are two notions or two relations going on, right? We have existence and containment. So an entity exists in a single associated graph space, right? That's like in a database, right? That's where it actually lives, right? While a node or relationship is contained in at least one or more graphs, right? So we're considering a model of overlapping graphs because we think here that there's a lot of richness to be found in that world. So what's the hello world of returning graphs from Cypher? Could be this query, right? Cypher signature statement, match from A via R to B, extended with a return clause that just say, I want to return this as a graph, right? And of course, that asks the question, what's the underlying model? And that is a bit richer than what is presented here on this slide. And that is the idea of switching to a model of streaming graphs. So when you look at the model of Cypher today, of course, it is essentially returns a table, or if you prefer the streaming database theory point of view, it is a stream of records, right? And you could switch this model to be a stream of graph records, which are essentially little property graphs themselves, right? So record fields become properties of the graph, right? And then, of course, each record can contain nodes and relationships because it is now a graph, right? So we have two, again, a bit like this existence and containment, we have two notions here. We have a notion of a current graph record, in essence, the same idea as the current record, right, in a relational query. And we also have the notion of the current data graph and its associated graph space, which is essentially the graphs that we're currently querying, right? So we have these two things happening in a query. And so the canonical model of Cypher would be to return a stream of graphs. So in the query below, again, match A via R to B, return graph star, gives us a stream of graphs that correspond to all the individual pattern matches, right? So that's the idea, that's the core idea. Coming back to how do we actually return a single graph, the idea is here, going back to the Hello World slide, to push it all together and say that is essentially an aggregation problem. So what you essentially have to do is you take your stream of graphs and you union all the tiny graphs, and then you return a stream containing a single graph, right? So we also can just return one. Oh, yeah, great, security. Summarizing again the key ideas, right? Switching to streaming graphs or graph records instead of records, right? Of course, staying within the current model of Cypher where entities are references or treated as references. We had also that pop up in the morning as a topic. provide easy aggregation of the graph elements and projections so that you can easily do this kind of union thing to get to a single graph. And I think worth pointing out that naturally extends to other set operations, right? You could also say I want to squash all the pattern matches together in an intersection, if that's what I'm after, right? As a second topic. And maybe last not least, it will be interesting to also look at nesting and unnesting operations in this context. Let's look at some queries. 1 and 2, right? Return graph. And there we already see the idea for a new kind of syntax in Cypher. Cypher is a language very rich in pattern syntax, so we want to introduce a new kind of syntax for graph patterns, for kind of matching graphs from the current graph space, because I think that's actually important to have a discovery mechanism for finding graphs in your database itself. And here we kind of propose the idea of having some kind of URL scheme. I think Alistair talked more about that in depth yesterday at the Open Cypher Implementers meeting. And the second query, you already see that that notion naturally extends to accessing views, which of course can be understood essentially as parameterized producers of graphs, right, against which you query. So then the next query number 3, here we show the matching, essentially, match G with the labels Autobahn and road, where the limit, where G.limit is bigger than 120, right? We're likely in Germany at this point. And then return graphs from G. So what this does is it looks into the graph space, it finds all the graphs having these properties, and then it streams all of them back to the user, right? So that you can get the whole set of them, right? And last not least, important, I think, the idea of being, of course, that's one of the main motivations of doing all this, the ability to actually enter a graph explicitly and querying inside that, and then returning what one has found, right? Next one. Yeah, let's look a bit more at querying graphs, right? First one shows Cypher's new subqueries extended with the notion of subgraph querying, existence subqueries. So we first do a plain pattern match in the default data graph provided by the session in which the user is, and then extended with the notion of, you check. Essentially, you have two persons that are loosely connected, and you check if they perhaps are more intimately connected in another data source, in this case, if they are alumni of the same university, right, or something like that. And then the last one, or on this slide here, is the idea of matching graphs that represent whole industries. Match G, which is an industry, which is thought here as a chain of organizations with dependencies between them and depending on resources. So this is the idea of treating graphs really as objects, right? And then we try to find out essentially if one of the manufacturers in one of these industries depends on a resource that has been, declared as scarce by some study that looks at things like rare earths and similar. So we have we first find graphs, then we go into an existential subquery, then we look for these studies which give us information about scarce resources, and then we go further on and check, actually is the graph that we found initially here, right, does that actually contain a manufacturer that depends on one of these scarce resources, right? For a more complex example here. And then we return all the relevant industries back to the user, right? Next, set operations are kind of interesting because if you stick with the classic relational notion of set operations, that's not really what you want, right? If you do, you also want that. You also want to take a stream of graphs and compute the union, right? But you also want to do the union between the graphs, right? And so the question is, how does this fit into this model? And here the proposal is to essentially rely on a cross product, or basically to do pairwise intersection. So if you have a stream of graphs coming in on the left, a stream of graphs coming in on the right, you do pairwise and you fuse the graphs pairwise with set operations so that you actually can combine the extents of the graph, right? Instead of working on the set of graphs, which is a different notion here. And of course, that would all extend to further set operations, union, exclusive union, etc., etc. And then we see more examples here in query 2, where we work again with Cypher's new subqueries. And then last not least, query number 4, that we still think it could also make sense. It's nice to have set operations at a query level, and for many users it's nice, but sometimes you just want to work with graphs at an expression level, right? Just look at a query like this, like return g underscore today minus g underscore yesterday. I think that speaks for itself in terms of expressivity, right? So actually this may be a case where it makes sense to consider allowing similar operations exist on the 2 layers that most query languages have, which is the expression layer and the operator layer, right? So yeah, inline views, of course, right? Once you have all this machinery, you can of course get graphs from your database, right? But of course you could also just define a view in graph. Define it using a Cypher query. This is where conditionality comes in, right? Here we have a big query using actually the new proposed syntax for dealing with node isomorphism, right? Match unique nodes, return graph, match some other unique nodes, return graphs, get the big union of all of that, right? And then match in the result of it, right?
Would you then get also edges between those 2 union graphs?
Yes, possible, because graphs are overlapping.
Because graphs are
overlapping. Overlapping. So the same node can be in many graphs. Even the same relationship can be in many graphs.
But if they are overlapping, it means that the reference of it's by reference.
Yeah, it's by reference.
But then if you return a node, will you get all its relationships already? So then you're always returning everything.
No, I think you will get, it's all based on the notion of pattern matching here. And since pattern matching happens inside a graph, you will get the relationships that are in that graph from that node. I mean, because you want to be in a world of multiple graphs. I mean, I think the idea of always returning all relationships that could be in any graph, I think that breaks down as soon as you move on to federation, for example. I mean, the notion of all that could be said about a node is not really viable in the federation setup. So I think that is a more sensible definition here. And I haven't went into this, but of course it's possible to come up with the notion of graphs that represents all nodes and relationships in the graph space, which would essentially allow you to address that point if you're after really getting everything that has been stored in a specific physical database. So yeah, I'm getting to the end of time, so I'm going to skip this mostly. Of course, Cypher has a rich update language, and I think that naturally extends to updating, right? I mean, you can create graphs. It's interesting, there are an interesting set of operations there. You can create and delete graphs, you can set and remove properties and labels, but you can also, that's kind of new, add and remove nodes and relationships to a graph, right? That's different, right? That's something we haven't had to consider before. And more, copying, merging. So further steps on this, we are actively exploring this whole area. We're looking at alternative approaches. If you have ideas, we have a Cypher request we have a requirements request out called CERT 20182, where we really ask the community to give feedback on how we should do this, if there are alternative proposals, how to extend Cypher with multiple graph querying, right? There's some interesting ideas here also, relationship to type theory, stream processing. I don't have the time to go into this. There's some question around if this notion of data graph versus this graph should be generalized further. And of course, we're actively looking at implementation concerns of this, but I think we can certainly implement this. So summary, multiple graphs are the next evolutionary step for Cypher. They extend the property graph model while preserving its original characteristics, which are ease of use, schema optionality, and data integration. Right, and that is, these last points, I've highlighted them because I think they often get lost in the conversation when you talk too much towards SQL. It enables analytics, views, graph management, modeling, visualization, graph streams. There's like a host of interesting things we can all do the next 20 years if we go down this path, right? And I think it's a great fit for Cypher's general approach to be really an application-oriented, human-readable, very successful language, right? And yeah, there's a lot of topics to be explored, of course, also on the theory side of things, right? Views, lifetime, snapshots, planning, federation. Don't know where to stop, actually. So that's it, essentially. Cypher 2018. We're going to do a lot of changes, I think. We're going to evolve the language further and further, and we really would like everybody to join us, contribute. Let's build the world of multiple graphs. Join the Open Cypher implementers group if you're interested, or if you're not coming from an implementation point of view, take part in our open process, right? Yeah. Conclude the talk. Can I go back to this? Ah, yeah, there's the numbers, okay. Yeah.
So this looks like you're subtracting two graphs.
Yes.
How do you deal with problems like flaming edges? So if you're deleting a node and it still has an edge attached.
Not allowed, essentially. You would remove the edges as well.